Hello everyone, welcome to Standard 6 Physics class. Today we are going to discuss about the chapter Light. In this chapter we will study about rectilinear propagation of light, pinhole camera, shadows, natural shadows, eclipses. How does the eclipses form? So let us proceed to discuss the each topic one by one. First of all, we discuss about the rectilinear propagation of light. So, first we know what is light. The chapter What is light? What do you mean by light? Light is a form of energy that produces the sensation of vision in our eyes. You might have seen a straight, narrow beam of light. You might have seen that a straight or a narrow beam of light striking through a tiny gap in the window curtains. You see, such type of rays. Similarly, at night, the light from the headlight of bike seemed to travel in a straight line. The light from a torch seemed to travel in a straight line. There is nothing common about light in both these examples. So light beams from both the sources appear to travel in a straight line. The property of light to travel in a straight line is called the rectilinear propagation of light. Remember, light always travel in a straight line. Light always travel in a straight line. The property of light to travel in a straight line is called rectilinear propagation of light. The path of light is denoted by a straight line with an arrow in the direction in which it is traveling. This straight line with an arrow is called a ray of light. You see here, the path of light is denoted by a straight line with an arrow and the direction in which the light traveling. The arrowhead shows the direction along which the light rays travels. A collection of rays is called a beam of light rays. A group of light rays or a collection of light rays is called the beam of light rays. These are the beam of light rays and this is a ray of light. Clear? Now, pinhole camera. This is all about the rectilinear propagation of light. Rectilinear propagation of light means the light rays always travel in a straight line. This property of light is called rectilinear propagation of light. Now we discuss about pinhole camera. A pinhole camera is a simple closed box device used for obtaining image. It does not have a lens. One of its sides has a small hole. This is the picture of a figure of a pinhole camera, and there is a hole. One of its side through which image of an outside object is obtained on the opposite side of the box through rectilinear propagation of light. So what is a pinhole? A pinhole camera works on the principle of rectilinear propagation of light. A pinhole camera is an application of rectilinear propagation of light. Remember, it is a very important point. Pinhole camera works on the principle of rectilinear propagation of light. We may also say that pinhole camera is an application of rectilinear propagation of light. The principle of rectilinear propagation of light is applied to form pinhole camera. Now construction. How do we construct a pinhole camera? We construct a pinhole camera using two cardboard shoe boxes, or a small and other large. One is small and another one is small. Follow this step. Must cut open one side of each box. Make a tiny hole in middle of one side of the larger cardboard box using a pin. See, this is the hole. Cut out a square window in the smaller cardboard box. This is the smaller cardboard box, and this one is the larger cardboard box. In the smaller cardboard box, a square window is cut out. Now cover this square with a butter paper or grounded glass so that it serves as screen. Okay, cover. Now slide the smaller box. This is the smaller box. Now this smaller box is slided. This is the hole. This is the square. Cut out square piece, and this is the hole. Now the smaller box is slide inside the larger one in such a way that the side with the butter paper in inside. Make sure that smaller cardboard fits the larger cardboard perfectly. The distance between the pinhole and the ground glass screen may be adjusted by sliding small cardboard inside the large cardboard box. Your pinhole camera is ready for use. Now working with the pinhole camera. Suppose a candle AB is kept. This is a pinhole camera, and the second burning candle which is placed in front of the pinhole camera. Now light rays from the top of the candle, from the top of the flame of the candle, that is from the point A, is passes through the pinhole camera and falls on the screen. Now another ray of light from the bottom of the candle, which also passes through the hole of the pinhole camera and falls on the screen. Let that point be B dash. And another ray of light from the middle of the candle passes through the pinhole camera and falls on the screen at a point. We see that the rays of light meet at the center of the pinhole camera at the pinhole and cross each other. They reach to fall side on the screen. Thus an inverted image. AB is the object, and here B dash A dash is the image. In the object the flame is upward, but in the image the flame is downward. So such type of images are called inverted image, an upside down image. Inverted image means upside down image. Size of the image formed by pinhole camera. The size of an image depends upon the distance of the screen. Distance of the screen. This is the screen from the pinhole, and distance of the object from the pinhole. Distance of the object from the pinhole, and distance of the screen from the pinhole. If we increase the distance between the screen and the pinhole, the size of the image increases. The distance between screen, this is the screen and pinhole. When the distance between the pinhole and the screen is increased, the size of the image increases. You see, the size of the image is larger than the size of the object. This is the object and this is the image. The size of the image is larger than the size of the object. If you decrease the distance of the screen from the pinhole, the size of the image decreases. You see, this is the object, pinhole camera, and this was the initial position of the screen. Now screen is shifted towards the pinhole. Now you see This is the object and this is the image. Now the distance between the screen and the pinhole decreases, as a result of which the image size decreases. Now we discuss about shadow. Shadow. We all know that light travels in a straight line. So when a beam of light falls on an opaque object, the light rays traveling along the straight path are stopped by the object, while rays pass around the edge of the object continue on their path. When the path of a beam of light is obstructed by an opaque object, a dark shape forms behind the object on a screen, says a wall. This dark region is called a shadow. Since the shadow is formed due to the absence of light, it is always black. So here we discuss about shadows. What is an opaque object? An object through which light rays cannot pass. So when a beam of light falls on an opaque object, light rays traveling along the straight path are stopped by the object, while the rays which pass around the edge of the object continues on their path. When the path of the beam of light is obstructed by an opaque object, this opaque object means an object through which light rays cannot through which light an object through which light rays cannot pass. A dark shape form behind the suppose this is an opaque object, this is the source of light, and this is screen. We arrange in this manner so that now when we place the screen and in front of it an opaque object and in front of it source of light, when light rays falls on the opaque object, the opaque object obstruct the path of light, obstruct the light rays to pass through it. Therefore the light rays pass through the edge of the opaque object and forms a dark patch on a screen behind the object. That dark patch is called the shadow of the object. Some interesting point about the shadow. You cannot see a shadow in the night or in a completely dark room because there is no source of light. You cannot see shadow when there is no opaque object even if a source of light exists. A shadow is always formed behind the opaque object. This is the opaque object and behind the opaque object a shadow is formed. This makes the shadows appear black. Translucent objects form faint shadows and transparent objects do not form shadows. Translucent object means the object through which light can pass partially. Means some part of the light rays can pass and some part of the light ray cannot pass through the translucent object. Transparent objects are those objects through which light can pass easily. For example, glass. So condition for formation of a shadow: a source of light, an opaque object obstructing the path of light, and a screen behind the object. These three are the very essential things for the formation of a shadow. Now, size of a shadow. The size of a shadow may not be identical to the size of the object because it depends on the following. First, position of the source of the light. First point is the position of the source of light. If the distance between the object and the screen is constant and the source of light is moved towards the object, then the size of its shadow increases. On the other hand, if the light source is moved away from the object, then the size of the shadow decreases. Position of the screen. If the distance between the object and the source of light is kept constant, and if the screen is moved away from the object, then the size of the object shadow increases. If the screen moves towards the object, size of the shadow decreases. Size of the source of light. A point or a small source of light gives sharp shadow that is equally dark all over. On the other hand, when a light source is bigger than the object, this shadow has two regions, a darker central part and a lighter outer part. Distance between the source of light and the object. If the distance between the source of light and the screen is constant and the object is moved towards the source of light. When the object moves towards the source of light, then the size of the shadow increases. If the object is moved away from the source of light, then the size of its shadow decreases. A shadow formed by a large source of light has two sections or two parts. One is a darker central part called the umbra and the lighter outer part called the penumbra. No light from the source of light reaches to the darker area on the screen, that is the umbra. Thus the umbra remains dark. However, the penumbra or the outer lighter part varies in brightness. It means that the lighter from very dark near the umbra to very bright at the outer part. This is because the penumbra receives a few light rays. Let us perform an activity to show the light formed by light source by a light source larger than the object by this and by the smaller one. You see here the source of light shadow formed by a source of light is bigger than the object. So what do you observe? When the light source is bigger than the object, a shadow has two regions. You see a shadow has two regions. This is the darker central region and a lighter outer part. This lighter outer part is called penumbra and this darker central region is called umbra. Here in the second case, the source of light, shadow formed by light source smaller than the object. The object is smaller than the light source is dark without any variation and in darkness. The shadow is completely darker region. Clear? You see sun, this is the sun, moon and earth. When light rays from the sun falls on the moon, you know that moon is an opaque object. It forms a large patch on the earth. And the shadow has two parts. One is a central darker part and another is a brighter part. The central darker part is called umbra and slightly brighter part is called penumbra. Now we discuss about natural shadows and eclipses. We know that a shadow is formed when the light coming from a source of light is stopped by an opaque object. In our solar system, the sun is the main source of light. The earth, the moon and the other planets are opaque bodies. Whenever the light from the sun is blocked, a shadow is formed in the space. However, we cannot see the shadow because there is no screen. The solar and lunar eclipses are a play of the shadow in the space, but we are able to see solar lunar eclipses, because in both the cases our Earth or Moon act as a screen. So, first of all, we discuss about solar eclipse. The Earth, you know that the Earth revolves around the Sun and the Moon revolves around the Earth. At the time, Sun, the Moon, and the Earth end up begin a straight line. In several, a time comes when Sun, Moon, and Earth comes in a straight line. What happens at that time? Sun is partially or totally blocked because Moon comes in between the Sun and the Earth. So the light rays coming from the Sun is obstructed by the Moon. The people living, so a shadow of the Moon is formed, and this shadow falls on the Earth. The people living in the part of the Earth which falls under the umbra region of shadow of the Moon witnesses a total solar eclipse. They see complete dark solar disk. The Sun in the umbra region is completely blocked by the Moon and is called the total solar eclipse. The people living in that part of the Earth which falls in the Moon penumbra region of the shadow witness a partial solar eclipse. This is because in this region the light coming from the Sun is only partially blocked by the Moon. When the light rays coming from the Sun is completely blocked by the Moon, at that time it forms a total solar eclipse. When the light rays coming from the Sun is partially blocked by the Moon, at that time it forms a partial solar eclipse. As the Sun is the partially blocked by the Moon in the penumbra region, it is called partial solar eclipse. Now we discuss about lunar eclipse. When the Sun, Earth, and Moon comes in a straight line, the Moon moves into the shadow of the Earth, and the lunar eclipse is caused. When the Moon is in the penumbra region, it is totally covered by the Earth's shadow. This is called the total lunar eclipse. When the Moon is partly under the umbra and partly under the penumbra region, it is called eclipse caused is called partial lunar eclipse. When the Moon is totally in the penumbra region, there is no eclipse, but the Moon appears tall and reddish. Then the Moon moves outside the penumbra region, it again brightly shine brightly. You see, this is the Moon. This is the umbra region. This is the orbit, and this is the penumbra region. While orbiting around the Earth, and this Moon reaches the penumbra region, it appears dull. When it completely covers the penumbra region, it again appears reddish. At that time, it shine outside the penumbra region, the Moon shine brightly, and when it is in the penumbra region, it appears dull and reddish. Watching an eclipse. Look at the sun directly can harm our eyes and may cause permanent damage to our eyes or even blindness. Hence, we should never watch solar eclipse with naked eyes. We can watch a solar eclipse by using glasses which are specially designed for the purpose of watching sun or the solar eclipse. However, the moon and the lunar eclipse can be seen directly with naked eyes. So, what do you understand? We can see lunar eclipse directly with naked eyes, but we cannot see solar eclipse directly because it harms our eyes. So this is all about the chapter light, and with this here chapter is completed. So thank you very much for watching this video.